All right, so we'll talk about precipitation now. We talked about clouds in the last lecture. Now we'll talk about the stuff that falls out of clouds. Specifically, like what are the mechanisms that form precipitation? Because the vast majority of clouds do not produce any precipitation. Well, why not, right? So here we go. Cloud droplets are really incredibly tiny. Remember, a cloud is really a liquid, right? It's all spread out though, really thin. And each of those droplets is only, about twice the width of a cell in your body, so they're extremely microscopic. In order for those droplets to be heavy enough to fall, they have to grow by a factor of like a million, which is a pretty big job, really, for something so tiny to do. And one of the ways we understand how this works is called the Bergeron process, named after one of the scientists who sort of developed how this works. So part of the key to this is that up in the clouds, we have what's called supercooled water, right? So really high up in the atmosphere, it's way below freezing, around minus 40 Celsius. Fun fact, minus 40 Celsius and minus 40 Fahrenheit are the same temperature. So anyways, when they're that cold, they can remain liquid, but as soon as they contact any kind of surface, they will immediately crystallize into like these microscopic ice crystals, right? And that's the first step in all of this. Also, where you have clouds, remember, we talked yesterday about how clouds do exist, and they exist at the dew point, and that dew point is always somewhere in the air, so why aren't there always clouds in the air? Well, because you have to get the moisture up there, right? So where you have a cloud, we say it's super saturated. There's an abnormally high concentration of water, and this abnormally high concentration of water means this initial little ice crystal is going to bump into lots and lots of water vapor in the air, and all of that water vapor that contacts the ice crystal is going to immediately freeze also. And that keeps adding mass to the object over and over and over again. The rapid growth continues as that crystal floats through the cloud. So yeah, it's a solid crystal of ice floating around this stuff, but they're so incredibly small and light that they basically float, like they were gases, but they're not. So anyways, eventually the snowflake becomes heavy enough that it can fall, and well, voila, that's precipitation. Even on summer days, rain might start off miles up in the air as a snowstorm, or at least, a little bit of snow. It's not at all that uncommon. So this picture here is a really simplified illustration of what's going on. We have individual H2O molecules in cloud droplets in a tiny little snowflake. Well, every molecule of water or every droplet of water that touches it makes it get better, and eventually it's heavy enough to fall. But in the summertime or in other times of the year, it is warm enough where this never starts off as snow. It always starts off as water. And that's a little bit trickier for reasons that we won't get into right here, but we will get into in class. But basically, water droplets can collide with other water droplets, but in order to get a start, they have to cling to what's called a condensation nuclei first, and that was in our last notes we took. So those water molecules are really, really small, and there's the surface of the condensation nuclei in comparison. So it's way bigger. It's like 1,000,000 times the size. If you look carefully, it is indeed a curved surface. So this puts it into scale a little better. Now these condensation nuclei, if you remember, they're like particles of smoke or salt or dust. Again, really, really, really tiny, microscopic, but small enough that they float and linger in the air for a long time, right? And then it collects and collects until it's heavy enough to fall, and then it's rain. Okay. There's lots of different types of precipitation. It's not just snow and rain. There's hail, there's sleet, there's glaze, there's which is also called freezing ice. So why do those things happen? Well, whatever reaches the ground, it depends on the temperature profile of the bottom part of the atmosphere, right? And that, well, I shouldn't say the bottom part of the atmosphere because all weather occurs in the troposphere, which is the bottom part of the atmosphere. I mean like the bottom couple of kilometers, really. So Rain and snow, not much really to say about this. Technically, a raindrop has to be more than half a millimeter wide. If it's less than that, then it's drizzle. So, drizzle is an actual technical term. Usually, people use it when they're talking about light rain, but that's not it. It's when it's like misting outside, and it's not common, but it happens. And as far as snow goes, I mean, if it's cold, it snows, right? When the closer it is to 0 degrees Celsius, which is 32 Fahrenheit, we get what we call wet snow, right? And wet snow is when like really chunky snow, like this, falls out of the sky. So if you look carefully at this, these are actually like a whole bunch of snowflakes clumped together. And then when it hits the ground, it might not necessarily melt, but the snow is really kind of, I don't want to say slushy, it's not quite the right word, but it's really, really soft, right? That's what we call wet snow. Dry snow happens when it's really, really, really cold out and it snows. We'll talk about that more in class. Sleet is like the little tiny ice pellets, right? And what happens there is you have rain, but the raindrop, usually this happens because it's really windy down at the surface. So that wind chill freezes that raindrop in midair, and then when it hits the ground, it's a frozen raindrop. It's a tiny little piece of ice. And then freezing rain is different. So sleet is kind of like frozen rain. Glaze is freezing rain, right? So we have the super cooled water again. So the water is cold enough to freeze, but it remains liquid. That can happen. But as soon as that rain hits the road, hits your car, hits a tree or whatever, it freezes. And we experience this in the winters, pretty much every season. We have at least a few freezing rain instances. Hail, we can only get hail in the summertime. And hail can only be formed by gigantic, the storm clouds, right? The cumulonimbus ones they can be well over a mile tall. They can actually be up to 10 miles tall, right? What happens is it starts off as either a little ice pellet or a snowflake, and it stays inside the cloud and keeps bumping into more and more water molecules and gets really gigantic. Usually, this can only happen in the summer when we have these kind of extreme storms because you have a cold and a warm front colliding with each other. And remember, the warm front lifts up, but this also creates what are called updrafts, right? Which is sort of like a vertical wind. And that pushes these hailstones through the cloud multiple times. So it just simply has gone through the collecting process, right? A whole series of times. Kind of like what you see in this picture, right? And then that's what makes it so you get this really gigantic hail, right? The largest ever hailstone, at least that we have found, fell in South Dakota. And we talked about this before. Here's the picture of it. So it was 1 ounce shy of being 2 pounds. And it's about the size of an NFL football. In reality, and you can tell by looking at it, it's a whole bunch of hailstones that got glued together up in the cloud. And for some reason, it just didn't break and somebody stumbled upon it. So here, maybe to illustrate this a little more clearly, are all of these different types of precipitation. Yep, if the ground is freezing just before the rain hits the ground, then it can instantly freeze. If the snow melts way up high and then has a long time to travel through the atmosphere, then it might freeze before it hits the ground, and there's your sleet, right? So this is what sleet looks like, little tiny frozen raindrops. There you go. And this is glaze. So glaze is really cool because when it falls on things, it creates sort of a barrier around them, right? So you see this kind of thing. It's not too common in either the early or late winter, sometimes in the middle of winter.